Thank you for joining us today, and I hope you are enjoying the videos. Give me a thumbs up in the comment section. And in this video too, we are still on set, we are still on algebra and trigonometry, and we are still on let us practice. And this particular video is going to be fun. I'm sure it's going to be fun. Let's jump right in. So here we are going to, they will give you the function. You need to change it before you get it done. Now let's look at this one. We are still on the De Morgan's law, right? So let's assume I have a minus, right? Let me say a another minus or difference b. And I want to show that this is the same as a intercept b. Wow, that is so nice. That is so nice. So now you see this one, for us to prove, first we need to make sure we change this one, the whole of this, into what? The other form. And we said the difference always goes what? Intersection. So anytime we want to change it, we need to change it to intersection. So how can I rewrite this again? So what I'm going to do is a minus b. Now look at this. You can see that this minus here is affecting everything in the bracket. That's what we need to know. This minus here is affecting everything in the bracket, like in a sense that if I have minus of a plus b and I want to multiply, this one will be minus a, let me say minus b. But here is not the case where we are going to multiply, but I just want to show you that it affects everything in the what? In the bracket or the parentheses, right? So they can rewrite this one as a. So I'm coming to change the difference to intersection, right? So this one will be intercept. But don't forget, I'm not going to use this one because this one is affecting all the bracket. So I'll open the bracket again. I have a again. Then I have another minus here, right? What's the difference? Intercept. But this difference here is affecting only the b. So this one can be written as b prime or b complement, because when I'm changing this to intersection, this is actually affecting only b. So that's the reason why the complement is affecting only b. Now let's look at this. This one was affecting everything in the bracket. So when you are done, you put the complement on the top there. So this right here is the same as this. Good. So this is how you can change it before we can start going. So now we can see that a intercept, b complement, and this is the same as a intercept b. So that's the reason I said this example is going to be so exciting. Why? Because we need to be able to change this or this into this form before we can proceed solving. Right, this is going to be an exciting proof, exciting journey to get into the final answer, because I can't even imagine. Okay, so let's get to how we can figure it out. So now let's go through the same process, the same idea. Let a intercept b prime belongs to a intercept b. Then we are going to go back. So this is one of the example that I'll be telling you. This one, when you are doing it, is better for you to use a when you are done solving this, like when you are done solving the first one, when you write this one and when you are done solving this one, it's good for you to use the if and only if, because this one, when you are moving from here to here, you see that is kind of weird. But because of we are going to solve this one, you can just repeat the same result by taking it from down to the top. I'll show you how to. So let's go through. This should be x belongs to this, and we need to have let x belongs to this too as well. So let's start with x belongs to a intercept b prime. This is going to this is going to be so exciting. I can't imagine how this is going to be. Okay, let's get through. So we have this one, we have two terms. Like this is giving us two terms. This is in the bracket, so this is one term. You have another term here. So this one can be written as x belongs to a and x belongs to A intercept B complement complement. Now let's go ahead. A, and now we need to change the complement on the top here first. So that one is going to give us x belongs, it's not in A intercept complement. Remember, we apply this, not this, right? So this is the one that we are using here, like mathematically wrong, but I'm trying to show you how it's supposed to be good. So this is what you are going to have. Then now we can expand. X belongs to A, and here x is not in A, so the intersection becomes n. X is not in B complement. Good, but let's look at something here. Here we are saying that x is in A. At the same time, here we are saying that x is not in A. So what are we trying to say? So what we are trying to say from here is, you can see that this right here is going with this complement here. It's not with this one. And even when you look at our proof, we don't have something like, because if I want to change this one, then this one will be x belongs to A prime. If I want to change it, like x belongs to A prime. And in our question, we don't even have A prime there. Do you see that? So the only thing that we are going to do is we are going to make sure we are going to leave this guy out. Like, the idea is that, if we are talking about something like something here, look at something here. If we are talking about um a intercept B prime, this is like A only. Is that right? Like the one in the bracket here, like, I mean, A intercept B prime is actually A only, right? And if I pick A only prime, because all of them is with prime, then A only prime will be equal to what? B. Let's draw the diagram and see. So if I have this here and I have A, right? So the first thing that we are going to do is we are going to do A intercept B prime. So what is A intercept B prime? A intercept B prime is like A only. So what is A only? Just here. Then we said, okay, now let's also take another complement. Everything complement. Everything complement here is A. So A complement, A only complement will be something like this. We have another point, and this one will be A and B. So A complement means that we are going to subtract it from B. So this one will be just this. Why? Because we are just picking only A only from it. So it means that everything on this side is actually B. Just B. Like as we can see here, it's just B. So that's the reason why the contradiction is coming here. But you see, if you follow the strategy that I'll be giving you, that whenever you are done expanding, look at the right hand side. This one will tell you that I don't need this guy here, right? Without going through all this should tell you that I don't need this guy. So this guy should just go away. Just rain, go away. So we just make sure it goes away. So now we are going to have x belongs to A, and so I'm just going to make sure this guy goes away. So here will be left with, so here will go away, so it will be left with x is not in B prime. So let's see what happens here. This, and now x is not in B prime means that x is in B, right? So here x is in B. As we can see from here that we saw that now the answer here was just B, which we have gotten. So the one at this side is actually giving us the B. And from there we can say that we're going to have x belongs to A. Then we are going to change this one to, intersection, and we have it this way, right? So when I factor this and this out, it will have this end, which is the intersection in B, which gives us the same right here. So you see that now if I want to reverse it back, and I'm starting from this one, it's so complicated to get this. But the idea is that if you want to reverse it, what you just need to do is you are moving from down to top. So this one, you write this one first, followed by this, followed by this, followed by this, this, then you get to this place. But this one, because it's complicated, I will just use if and only if and only if, to just finish the proof for me. Good. So that now I can conclude that this guy right here are the same. These guys are the same. So I hope the video was so exciting, as I'm so excited to solve, because it's so exciting, should be able to find out what's next. So in the next video, more examples. We are going to bring another unique one, nice one, another nice example that when you see it, you can decide to pause the video and try and see if you can do it. And then I believe you can do it, right? So pause the video and do it. We've gone through a lot of journey by getting here. So right now, I think you've seen all the techniques. So in the next video, I want you to, when you get to the video, just pause it. When you see the question, solve it, and try and see. When you finish, play the video and see if we are going to get the same thing. I know, I believe you get